In this lesson, we are introducing what is called linear approximation. So back before technology could do some of these things that a calculator can do very, very quickly was how do you figure out square roots of values that are not perfect squares? And so there's a method called linear approximation to help figure out close to the value. It's not going to be perfect, but it could quickly get you to an answer versus going through a whole process of actually figuring out what um, the most accurate version of that, but I don't even know what the process is. So linear approximation is we are going to be creating a tangent line to help our cause. All right, so here's the idea. So to do a tangent line, if we're figuring out we're looking to do an approximation of the square root of 100.2. Well, I know that it's going to be really close to approximately the square root of 100, but it's not going to be the square root of 100, right? Like it's going to be close to it, but not. So I know the square root of 100 is 10. It's going to be close to it, but how do we get the decimal part of this? All right, I don't want to just guess. So we're going to use this right here. We're going to create a tangent line. And then we'll talk about, well, how do we know if this estimation that we got is higher or lower? So we'll talk about that as well. There's a visualization that we can help to make some sense of our answer. So we're going to create a tangent line, right? And so first thing is we need a slope. So we need an equation. So since we're doing the square root of something, our equation that we're going to do for our slope is f of x. For our equation, it's going to be square root of x. And we're going to make it derivative friendly. Right, so I'm going to turn in an x to 1/2. So slope equation is I bring the power down, I subtract 1, and then let me rewrite it one more time. So we have a 1 over, I'm going to bring that back down and turn it back into a square root. All right, so there's our slope equation. So I would like to find what's the slope at 100. So, and I'm choosing this because I'm plugging values in. And so I want to pick a value that's close to our estimation. And so we're going to use 100 as that point, right? I'm going to pick the closest point that I can. That's going to work out nicely. So what I have is I'm going to be creating this tangent line. I just found a slope equation. We're going to find the slope at 100, and we're going to find the x and the y value of our nice coordinate. Our nice coordinate is we're plugging in 100. Our equation is the square root of x. So when I plug 100 into that, my y value is 10. So that's my x, that's my y. So my tangent line is very, very close to this value, but not exactly on it. So if I find my slope at 100, I'm going to be doing 1 over 2 times the square root of 100, which is going to be 1 over 2 times 10, which is going to be 120. So our tangent line is y minus y1 equals m times x minus x1. We plug in our nice coordinate, so y minus 10 equals 1/20th for our slope at that nice point, and x minus our x value. So our tangent line is y minus 10 equals 1/20th x minus, I take a 20th of 100, I'm getting a 5. I'll add 10 over y equals 1/20th x plus 5. All right, so here's what we would do now. We would then take this tangent line, plug in the 100.02, and that work right there, the y value that it spits out is going to be approximately the square root of it. So visually, let's talk about what it is that we're just did. We're talking about a square root, and a square root has a graph like that. Okay, and we're further out down this thing, and so we're sitting here at 100. Right? And what I just did, as far as nice values go, we just created a tangent line at that point. But we know that if we plug in 100 into this, we can do the square root of 100, no problem. But I don't know exactly what the square root of 100.2 is. But if this is the real curve, the real values, 100.02 is awful close to it. So what if I could plug it into this tangent line? I would get that value when I plug it into this, which is close to the real value. And that's all I'm shooting for is what roughly is this value? It's not exact, and I'm okay with that, but I'm getting an approximation. And our approximation is going to be a little bit higher than what the real value is, right? And so that's why the closer you can get to where you build this tangent line, that when you're picking these nice points, the closer you can get to the estimation point, the closer you're going to be to that tangent point, which means the more accurate you're going to be. If I had picked some sort of a value like 9, my tangent line would be way over here. So my estimation would be way up here compared to what the real value would be, right? So this is where now I'm going to be plugging in 100.02. And this is where I do have to use a calculator. So 1 over 20 times 100.02 plus 5. So if I do plug that into the calculator, that would get me 5.001 plus the 5. So my my tangent line would get a value of 10.001, right? So it's giving me that value, which is just a smidge higher than what the actual value is. So our approximation for the square root of 100.02 is about 10.001. And I do know that that is an overestimate. All right, so there is my estimate. And if I actually plug it into a calculator and square root 100.02, I'm getting awful close. We went to 10.001, and that just goes to a 0.9. That thing rounds even. But our estimate is awful close to what the actual answer is. So that's using linear approximation. You create a tangent line based on a point that's as close as you can get to this value that you're trying to approximate, create your equation, and then plug in your estimate, and that's going to get you a value that's awful close to the real thing.